Now that you know what an initial and a terminal side is, what we're going to do is we're going to find all of our trig functions using a point on the terminal side of our angle. Okay, so in order to do that, we have to have an angle theta that's formed from an angle in standard position. Okay, remember standard position, your vertex point's at the origin, and your initial side is on the positive x-axis. Your terminal side is somewhere in the coordinate plane. Okay, so I'm going to give you a point on that terminal side, x and y. And when I give you that point, what we can do is we can figure out what the radius is using the Pythagorean theorem, because we can create a right triangle from our terminal side where the vertical leg will be y, the horizontal leg will be x from your ordered pair, the positive value of course, and then the Pythagorean theorem can give us the value of r, which will be our hypotenuse. So with that being the case, we can find sine by taking our y value, which comes from our ordered pair, and putting it over our radius. Since the cosecant is the reciprocal function of sine, we would just put r over y. Our cosine can be found by taking x, which is the x value in our ordered pair, and putting it over our radius. Since the secant is the reciprocal function of cosine, we would just have r over x. And then to find tangent, we'll put y over x. Y comes from the ordered pair, as does x. And then cotangent, being the reciprocal function, would be x over y. So my first problem here, we have the point 5 and negative 2 on the terminal side of theta. Okay, theta is our angle formed on the coordinate plane, but it has to be in standard form. We're wanting to find the exact values of our trig functions, okay? So the first thing that I need to do is I need to figure out what my radius is, and in order to do that, I'm going to use the Pythagorean theorem. But instead of a squared plus b squared equals c squared, we're going to use x squared plus y squared equals r squared, where x and y come from my ordered pair, and r is going to be my radius. So x squared plus y squared is equal to r squared. X is 5, so I'll have 5 squared plus y squared, which will be negative 2 squared, is equal to r squared, or 25 plus 4. Now, we get a sinking feeling when we see this because we know that we're going to have to deal with a radical, because to undo a square, we take the square root. So my radius is equal to the square root of 29. Now, I'm only going to use the positive on this one. So now I'm going to use r equals the square root of 29. That will not simplify since it's a prime number. My x value will come from my ordered pair, which is 5. And my y value will come from my ordered pair, which is negative 2. So I know r, x, and y. I can now go over here and find all my functions. So sine of theta is equal to y over r. Y is negative 2. R is the square root of 29. Now we created a no-no here. We cannot have a radical in the denominator of our fraction. So I'm going to get rid of it by rationalizing the denominator. And what I'll get is negative 2 times the square root of 29. The square root of 29 times the square root of 29 is just 29. 2 and 29 will not reduce, so we're good. Okay, now the cosecant is going to be the reciprocal of the sine function. So it's going to be the radius over y. So my radius is the square root of 29, and then my y is negative 2. We don't put a negative in the denominator, so I'm going to put it out to the side. Okay, I put it a little bit high there, but it's negative square root of 29 over 2. Now, my cosine is going to be x over r. So x is 5 over r, which is the square root of 29. And I've created the same situation with a radical in the denominator. So let's rationalize it by multiplying the square root of 29 over the square root of 29. 5 times the square root of 29 is just that. The square root of 29 times the square root of 29 gets rid of the radical, which is going to give you 29. 5 and 29 will not simplify, so that's my answer. 5 square roots of 29 over 29. Now my secant is r over x, so the square root of 29 is my r. My x is equal to 5. That's good, isn't it? So I'm ready to go to the next one. Tangent is y over x. So y is -2, x is 5. So I'm in good shape. Cotangent is x over y. See that right here. So x is 5, y is -2. So just bring the negative out to the side. It's not wanting to write down for me. And we get -5/2. Make sure you don't leave a negative sign in your denominator. Bring the negative sign out to the side. If the whole thing's negative, just bring it to the side. Okay? And that is how you find your 6 trig functions given 1 point on the terminal side of your angle. Now, if we go over here and we try to draw this, okay, we know the initial side, because this is standard form, has to start at the origin and extend on the positive x-axis. Now the terminal side is going to pass through the point 5 and -2. So that's +5, 1, 2, 3, 4, 5, and -2, 1, 2. Okay, so here is 5 and -2. So I'm going to draw from my origin to my terminal side. Okay, and then this is what my angle is going to look like. I know that since this is 5 and -2, my ordered pair, my x is going to be 5 units long. Now I can draw